Class, what's up? Welcome back to our next video. We are moving on to angle relationships in triangles. Alright, so we're specifically looking at angle relationships. Now, quite a bit of this should be review of class, or actually maybe not the notes themselves, but they work off of the things that we did in class. Alright, so we need to remember from class that the sum of the interior angles of a triangle is always 180 degrees. And we also need to remember that the measure of an exterior angle is equal to the sum of the measures of its remote interiors. Remote interior angles, excuse me. Okay? So now, with these ideas in mind, we have a few new kind of theorems that we can use. The first one is what happens when we have right triangles, alright? We know, no matter what, that if we have a right triangle, well, one of those angles is a 90. And then if we use that idea combined with the fact that the sum must be 180, well, we can say that A and B must, no matter what, be the other 90 degrees, right? Again, if C is 90, well, then there's no options but for A and B to together be 90 degrees. And so what we can say is the acute angles in a right triangle are always complementary. And that just means, again, equals 90. Alright? Well, let's use this idea a little bit more. Again, the sum of the interior angles must be 180. Well, now we're talking about an equiangular triangle. Equiangular, equal angle. Well, then there's no choice but for each angle to be the same. So let's set something up here. Let's say we don't know. And we are going to say if they're all going to be congruent, well, then they all better have angle measure x. Well, then if I add the three angles together and set equal to 180, I end up getting that 3x has to be 180, or x must be 60. So we know that no matter what, always and forever, if we have an equiangular triangle, those angles have to be 60 degrees. And we would just say the measure of each angle in an equiangular triangle is 60 degrees. Alright, hopefully you guys understood how I proved that. I knew equiangular meant that they all had to be the same, and I just set it equal to some variable that I wanted to solve for. So when I added the three angles together and set equal to 180, it turned out that x had to be 60. Alright? Now the last one, I call it the no-choice theorem. The book calls it third angles, but hopefully you'll understand why I say no choice in a second. So, what we have to understand here from our picture is that we have two sets of congruent angles, right? A and D are congruent because they have matching arc marks. Same with B and E. Well, if these two are congruent, as well as this other set are congruent, there's no choice but for the last pair to also be congruent. So we can say that angle C must be congruent to angle F. Alright? So if two angles of one triangle are congruent to two angles of another triangle, then there is no choice but for the third pair of angles to also be congruent. Alright? And again, I call it no choice because there's no choice. It's impossible for C and F to not be congruent. So now let's see if we can put some of this into action. So as we flip over, we got a couple of problems, a few problems that we're going to try. And let's take a look. Okay, so in number 1, we have the measures of the acute angles in a right triangle. Okay, so right off the bat, I know I'm going to draw a right triangle. Cool. And I know the acute angles have to be in ratio of 3 to 2. Now this is something that can be challenging, but if they're in ratio of 3 to 2, well then they have to be like 3 and 2, or they can be 6 and 4, or they could be 9 and 6. And what I'm really doing is I'm just adding 3 each time or adding 2 each time. And so the nice way to do this, guys, is I actually want to say that there's going to be some multiplier. I'm going to have to multiply both the 3 and the 2 by some number to figure out what the actual angle measures are. And when I say some number, hopefully you guys think, well, I want to use a variable. I want to solve for this, okay? So this looks like the bigger angle. I'm going to say that this has to be 3x. Now, if this other acute angle is going to be in ratio with 3x, well then it must be 2x. All right, and again, I know that if I multiply this 3 by some number, x, then I'm going to have to multiply the 2 by the same number to keep it in that ratio of 3 to 2. So this is kind of the setup. Now hopefully you can use your understanding of the right triangles, and we can say, well, what's true about the acute angles? They're complementary. So I would just set 3x plus 2x equal to 90, or 5x equals 90, or x equals 18. All right? So we're almost done. Please make sure you go back. What are the measures of the acute angles? Well, we gotta plug it in. So we have a 2 times 18 is 36 degrees. We have a 3 times 18 is, what is that, 24, 50, 54 degrees. And hopefully you guys noticed that if we went back and checked, those would, in fact, add up to 90. So we are good to go. Okay? Now in number 2, if you notice, we have an exterior angle, right? This segment, GJ, is being extended beyond the triangle, so this 126 is our exterior. And we learned that the measure of an exterior angle is equal to the sum of the remote interiors. All right, so that's kind of the thought process. Now we just have to plug in and go. Well, my exterior angle is 126, so that's going to be by itself. And then I know that the remote interiors, well, those are the two interior angles that the exterior angle is not touching, right? So this right here is out, because that's the angle that's touching the 126, which means my remote interiors are at h and j. So I'm going to just write 6x minus 1, and I'm going to add 5x plus 17. All right? Again, remote interiors. 1, 2. Hopefully you guys can see that. 1, 2. All right? Well, now we got to solve. Now we got to do some combining, so I'm going to rewrite this because I kind of goofed up how I wanted to do this. All right, so please remember, everything over here is on the same side, so please, we're combining first. I have a 6x and a positive 5x. I have a negative 1 and a positive 17, so that's going to look something like 11x and plus 16. Now we can go ahead and solve. We get 110 is equal to 11x, or we get x equals 10. Now, please make sure you answer the question. It asks for angle J, so you need to plug in 5 times 10 plus 17 is equal to 67. So our final answer for angle J is 67 degrees. Okay. All right. Lastly. Okay. Number 3. If you notice, I'm giving you information about 2 angles in each, right? So this is one where if I have two angles that are congruent to 2 angles in the other triangle, well then there's no choice but for the third set or third pair to also be congruent. Okay? So what I would probably say, and there's multiple ways to do this, but I would probably say, well, I can get this angle, right? If I know these two, I know I can get this third angle by just saying angle plus angle plus angle has to equal 180, right? The 3 angles of a triangle must add to 180. So, oh shoot, I wish I had a calculator now. What is that? 124 plus x is equal to 180. So now I know, oh, that's a 4, sorry guys. So now I know that x should be 56 degrees, all right? Well, what's great about this is now, if this is 56, what do I know about the other side? It also has to be 56. So I can set up a new equation. I can say 56 is equal to 2s plus 10, and I can go through solving this. So I would take away 10, and I'd divide by 2, and I'm getting that s should be 23. Alright? So hopefully these 3 types of problems that we just did in this video are a nice review and refresher on some of the concepts from class, as well as these new concepts that we learned in this video. Alright, so as usual, we will practice these concepts in class. I hope you have a great day. Peace.